Okay, record. Let's start. Today, guys, we will move to our fifth seminar, and today we will talk about another machine learning project. It's classification type of problem. As always, let me open our folder and let's create a new project. Open folder, desktop, and guide tribe. Yeah. Okay, let's create new folder. Sorry, it should be folder. You see, last time we discussed during the lecture number 5, we discussed about machine learning project, and we tried to solve a problem of regression. Regression problem, in general, when you are speaking about classical machine learning, you have two types of problem. You have regression and you have classification. Last time, our project was about regression problem. Regression problem is when we try to build a model to predict a continuous variable. Continuous variable is a variable which can be represented by every possible number on your number line, like it may be every decimal number or whatever. It is continuous variable. So, for instance, continuous variable is salary, height of people, mass of people, maybe I don't know, some physical parameters. This is a continuous variable. But today, on our sixth project, we will speak about classification problem. Classification problem is a little bit different. Because classification is a kind of problem when we need to predict a category. We need to predict is this person is male or female. And this category cannot be represented by decimal number, by float number. It can be represented by only like 0, 1s, some natural number, integers. So, okay, let's dive into this, and this will be classification problem. In practice, I would say that classification problem is even more important because in practice, you will see that 70 or 65% of your tasks will be about classification of object. And the remaining part, 30% approximately, will be about regression problem. Okay, classification task, not IPy. Okay, let me close this. And as always, we will starting with selecting our kernel and importing packages. Import pandas as PD, import numpy as np, import matplotlib for some graphic representation, pyplot as plt. Whatever we need, let's import Seaborn, maybe as SNS, and that's all for the start. We selecting kernel, and we are running our notebook. What else do we need? We need to have some data, because if you're trying to build a project, at least you need some, I don't know, CSV file. For today's talk, I suggest you to go on Kaggle, and let me demonstrate you Kaggle, and we will speak about Kickstarter dataset. Kickstarter project statistics. Yeah, is it this one? No, I don't like this. Kickstarter project. Yeah, this one. We will download this dataset. Where it is? Yeah, KS project. You see right now inside this Kaggle repository, we have two projects, one from 2016 and another from 2018. Both of this dataset is approximately 50 gigabytes. I suggest to download this one. Let's do it. It's take several seconds. Okay, it's downloaded. I also will share a link. Okay. Now let's unpack our data. Downloads, archive, and I will put it inside our guide tribe folder. Classification problem, archive. Oh, sorry. Let's unzip it. Okay. Yeah. Okay. Let's move back to our Jupyter notebook. Sorry, let me put it here, pin it here. How to do it? Sorry. I have this little plate with my face. Okay. First of all, as always, we are reading our data, df, pd, read, csv. Pass to our data. By the way, when you are working in Jupyter Notebook using Visual Studio Code, you can use this command ls. This is an abbreviation for list directory to check all the files which is inside your directory. You see that I have this archive file, and if I don't know what is exactly the names of my file inside this folder, I can do like this. I can specify pass to this folder and check which files I have inside it. This is quite useful. I use it almost every day, this feature. Archive csproject.csv. Okay, let's check. Let's check our dataset. What do we have here? Okay, we have some columns. And also, I forgot that we need to specify this ID column because we have it intrinsically. So index column equal to ID. What else can we do when we are reading data? You can additionally say to pandas that pandas need to parse datetime objects. You see that right now in this dataset, we have new type of object, deadline and launched. And this is a date. And date is a bit different from numbers. It's a bit different from categories. And when we are dealing with date, we need to apply a bit different methods. So today I will demonstrate you how you can actually process real dates. You see it's a bit different. And to parse this date, to put it inside the memory of our computer, we need to specify additional parameter when we are reading our dataset. It's called parse dates. And to parse dates, we will pass a list where we will specify names of this column. Deadline and launched. This two column has a date type format, date time format. Okay, let's reread our dataset. Okay, now it's looking better. Now let's just have a look at what we have in our data. We are speaking about Kickstarter. Let me demonstrate what is this Kickstarter. Kickstarter. Kickstarter is a big crowdfunding platform. I think it's located in United States. And the main idea of this platform is that you can actually create your own project. For instance, you want to like film a movie. You want to create your own movie, or you want to create some computer game, but you don't have enough budget, enough money to do so. And you posting your project on a Kickstarter, and you asking other people to give you a little bit of money just to donate you on this project. And for instance, you can check that this project, Go Chess, is a kind of mobile phone application. And people actually donated to this mobile phone application developer to help him in his project. And as a result, developer may provide to his bakers. Bakers is a person who donated to this project, free access or maybe premium subscription to his application. And actually, the idea of this platform that you are posting your project, you specify the deadline, as you have seen in our data. You have launch date, you specify the deadline, and then you are waiting if some people will donate you. And in our dataset, you can see that this donation column is called USD pledged. This is how much money actually people already donated to you. Also, you have here a goal. A goal is actually goal which you specified on this Kickstarter dataset. For instance, you see that this project about Go Chess has goal of $20,000, but it already collected $1 million. So it is like overperformed his goal almost 50 times. Yeah. And actually, this is an idea of this dataset that based on the knowledge about project name, project currency of donation, that is this donation was collected in USD, in euros, or rubles, or something else, based on country and category of this project, we need to predict what will be the outcome of a particular project. For instance, you see here, we have column state, and this will be our target. We will teach our machine learning model based on the information about category, goal, launch date, and so on, to predict what will be the final state of this project. You see that some projects are failed, some projects canceled, and some projects are successful, actually. Let me demonstrate you. df.state, we will use value counts. Yeah, you see, we just calculated the simple statistics that we have so many failed projects, and some projects just, yeah, actually not so low number, because the number of successful projects is almost on the same order of magnitude with failed projects. So yeah, it's actually okay. You see, we have many different states, and as we know, when we are starting data science project, we need to do some exploratory data analysis. I will do it like this. We will do some EDA. This will be our first title. We will do EDA. The first stage of EDA, we just explored what will be our target, and we can create some visualization to make it more clear for us. As always, we will use matplotlib. Okay. plt.py, plt.show, and also I will specify parameter iuto pct equal %% 1f%, maybe like this. Now will it work? No, it is not working. Unsupported character. What I forgot it? I don't know. Yeah, like this. No, not like this. Okay, I will delete this parameter. I forgot how to use it. Okay, and we will also specify labels. Labels equal to df. Let's actually create a separate variables for this. Number of states. And for number of states, we will use these labels. Okay. Let's execute this. Yeah, we see these numbers. We see number of successful projects. This is blue one, and we have no, blue one is unsuccessful project, which is failed, and the orange one is successful project. But also we have some categories which is kind of intermediate stage. We have some project which is still alive, some undefined, suspended, and canceled project. Actually, for today's for purpose to simplify our today's talk, we will remove all these categories, and we will apply a simple logic that a project might be either successful or failed. And all other categories, we will say that this is a failed project. Okay, let's implement this. If df.state equal to successful. And we will create this as df.target. We will just create a new column, and all our next models will be trained with respect to this new column. If state of our project is successful, this will be 1, like Boolean true. If the state of our project is unsuccessful, it will be 0, that another class. And this is the essence of classification problem. Now let's reiterate this stage, and instead of state, we will use target. Yeah, you see, I just removed all other classes to decrease the noise, and we just have 2 classes. We will need to build a model which can either predict 1 or 0, class successful or class failed. This is classification problem. Okay, we deal with our target column. Next to what we want to do, we need to understand what types of data we have in our data set. For these purposes, we will use a simple command dtypes. Yeah, you see that right now, on the contrary to the previous projects, we don't have three types of data: object, numerical and integer, float and integer. We also has a new type of data, datetype. And in a several minutes, I will demonstrate you how you can work with it. Also, we created a target which is Boolean format. It is true or false, 1 or 0. What else do we have? Yeah, actually, that's all what we need to do here. Also, let's use df.info to calculate number of columns of each type. How many columns we have? Okay, we have 1 Boolean column, 2 datetime, 5 float, 1 integer, and 6 object column. As you remember, object column is a category, and we need to apply label encoding or one-hot encoding to it. Float and integer column need to be treated in another way. You need to scale them. And datetime column, actually machine learning models cannot work with datetime, but they can work with features which you can get from a datetime column. Let me demonstrate you. Let's take this df and let's take column deadline. Let's actually select this column. Let's use method head. Yeah, you see this is these values are not applicable for machine learning model, but you can use a special method called dt, and you can actually take a year as an integer number from this column. This is pretty simple. You see, instead of having a column of datetime format, I created column of format int32. This is integer column. What else can you do? You can take months, you can take day, and whatever you can imagine, you can actually take this from datetime column. Let me demonstrate you. Right now, we will create several new columns. One will be called months, another will be called day, another will be called quarter, quarter. And we just create these columns as a new one. You know how to add columns. We just write like this. Sorry. Yeah, I'm here. Here, df dot months. It will be equal to this df dot day. It will be equal to this, and df dot quarter equal to this. This is how we can create new columns based on our datetime column. What else can we do? We can do the same transformation with our deadline column. No, it was deadline. Yeah, with our launch column. We have 2 datetime columns, so we can apply the same transformation with both of them. Launched. Yeah, you see launch column, and I can just copy paste this piece of code, and instead of using deadline, I will use launched. Launched. Is it writing like this? Oh, yeah, it's correct. Let me also change this. I will add just to separate columns, new datetime columns which we created from the deadline, and another one which we created from the launched. Okay, this simple commands allowed us to extract useful for machine learning models features from our columns, which has format datetime 64. Okay, let me actually re-execute very first cell, df.launched, and create new columns based on our datetime format. Okay, perfect. Now let's check how does this columns looks like. I will copy paste them. Year, day, months, and whatever we created, quarter. Yeah, like this. Okay, yeah, you see, we created several integer columns, and already they are more useful for machine learning model than datetime format. Okay, what else we can do with our dataset? Right now, we are on a stage of our exploratory data analysis. We understand that we have some datetime columns. We created new ones based on them. What else can we do? Let's continue our EDA and try to understand, is this success rate is somehow changed by different countries? Like check success rate by country. Let me demonstrate you dev.head. We have our column called we should have column country, I believe. Country. Yeah, we have column country. We have United States, Great Britain, and whatever. And now let's try to calculate average success rate by country. To do so, we can apply a simple group by transformation, group by country. And next, we will use aggregation function, target sum. Let's do like this, and p.sum is index equal to false. Not like this. Is index equal to false? Target does not exist. Why? Why it does not exist? I created this column right here. df.target. Let me check. df.target. Let's restart our notebook and run it one more time. We created the target here, so we should see it on this stage. Yeah, you see, right now I calculated a number of successful projects in each country. I aggregated our data set with respect to country. And for instance, you can see that in Great Britain, we have 12,000 successful projects. What else can we see in United States, whatever in Japan, 7 projects, and so on. Okay, but right now I just calculated number of successful absolute number. But to calculate actually success rate, we need to divide this number by the number of projects. One way to do so, we can just sum all this value and normalize each value on our row by total sum. But more kind of the better way to do so, we just can calculate mean. Since our target is a group of 0 and 1s, df.target. Let me demonstrate you one more time. df.target head. Since our target is a group of Boolean values, true or false is the same as 0 and 1s. True is equal to 1, 0 is equal to 0. False is equal to 0. Yeah, true is equal to 1, false is equal to 0. So if we calculate mean value, we will automatically normalize all the value and obtain a mean success rate by our country. Let me demonstrate you. Yeah, you see, each value is normalized. I can multiply it by 100. And for instance, I can, what else I can do? I can order it. Sort values by target. Sort values by target. Also, I will sort it in ascending order. Now it is sorted from the lowest value to the biggest, and I will sort it in an opposite way. Yeah, right now we inspected what is the success rate by different country. In United States, it's 37, in Great Britain, 35, and so on. So United States is leading in a term of successful rate. What else do we see? We see some strange value of country right here. I would say that this is an error, and this is exactly the point why we always do exploratory data analysis. Because errors in data, this is absolutely normal. You will see errors in data in every your project which you will try to accomplish. So right now we see an example of how we can find an error just looking on our data by our own eyes. Okay, so first of all, what we can do with this error? We can replace this value with some more reasonable country name, but we don't know what is the country it is. Another approach is just to drop this value, and the third way is just leave it as it is. So I suggest that in a first stage of our project, when we just read this data set, we will check that country is not equal to this value because this is an erroneous one. So it is not supposed to be here. Okay, we will do it later. What else we can do? We can try to visualize our results of success rate by country. To do so, let's use is index equal to false. Wow, crazy. No, I don't use this. You see what I created? I created a sum of country column. Is they just concatenated to each other? Okay, let's visualize the result of our EDA using heat map. From country converter, import country converter as CO and import plotly express as px. Okay, first of all, we need to convert all the names of a country into the ISO 3 format. COO, convert. To convert, we will use this index. Will be success rate by country. I will just store all the result of our analytics in a variable by country. Okay, I will store this result by country. I will convert it index and 2 from equal to ISO 3. Yeah, you see, right now I just converted the names of a country to a more reasonable format. ISO 3 is a kind of standard in industry. And also and right now I need to rewrite this column in my initial data frame. Okay, I do so. And next, let's call our method for coral. Okay, pass this success rate, and also we need location equal to index. What else do we need? We need values. Color. We need color. Color equal to success rate. Success rate state. Let me check one more time what we have stored in this variable. Target. It's called target. Color equal to target. Let's see if it works. Unexpected name. Is it okay? Sorry. Data frame. Locations. Oh, sorry. I should use locations. Okay, yeah. Right now, we just improved our visual understanding of our data. Let's actually see. We exploring Kickstarter project. And right now, you see that actually this project is not in all countries. And this project is only about European, American, and I would say the majority of English-speaking countries. What else can we like to say from this map is that the highest success rate is in United States. What does it mean for us when we are building a model? That if we would say that success rate is the highest in USA to our machine learning model, most probably it will improve accuracy of predictions. Okay, another, what do we see here? The lowest success rate is in Italy. It is 15%. The same idea here. If machine learning model knows that on average success rate is lower in Italy, most probably it allows our model to make better predictions in future. So this information about success rate by country might be a useful feature in our dataset. The process of creating a new columns or new features or new predictors, this is all the same word, this is a synonyms, called feature engineering. And when we actually exploring our data and see that some countries has much higher success rates than others, This is a good approach to create new features. What else? When we used these methods of applying to datetime columns, applying these methods to datetime columns, this was also a part of feature engineering. We tried to create a new feature based on existing ones. You can speak about feature engineering like many lectures in a row, but this is the most important part when you are building a model. And this one is the most creative one. To understand what new information you can obtain from existing one. Like getting this integer number from year, month, and quarter was okay. Adding additional information about success rate by country, it is even better. Let's try to add this new feature to our dataset. How to do it? We will take this success rate by country, and recalculate it in order to join it to our initial data. We have initial data. We will calculate this success rate by country, and using country column as a key, we will join our new feature to our data frame. Okay, let me recalculate it. Success rate by country. Success rate by country. What do we have here? We have country as a label. I will use reset index. I will actually use it right here. You see, right now, country used as an index. We don't need to do so. It is not handy way. I will reset it. You see, country now is not an index, and we created a natural index, which is integer numbers. What else do we need? We need to take our data set, and we need to use method pd.merge, I think. pd.merge is a method which allows you to concatenate two data frames. It allows you to concatenate it on axis 0 or axis 1, by rows or by columns. Let's do it. What does it take as an argument? You need to take left data frame. Data frame on the left is our initial data. It is df. And we need to take right. And right is success rate by country. Okay, what else do we need? We need to specify key column, which allows us to bring them together. And this column should be country. Will it work? Is it working? Let's see. Okay, yeah, you see, right now we created a new column, but unfortunately it's called target Y. You see that since our initial data frame has column target and we joined another data frame to it, it automatically renamed it to target Y. I don't like this. So to avoid this, we need to rename it in our initial aggregation. Rename. And what we will rename? We will rename target to what? To success rate. Let's do like this. Sorry, success to C, target to success rate, and axis equal to 1. By the way, guys, when your query is become too wide and you have too many comments in it, you can use this command. Sorry, not this. You can do like this. You just write slash, and you can put your comments on a next line. You can write slash here. Sometimes it's useful. It's make your code more readable. So if you will try to reproduce all the results, it will be easier for you to understand what's going on here. I'm just using slashes, and instead of having a wide row, I created several ones. Okay, what else can we do? We renamed our column. Let's check it. Success rate, and let's merge it. Yeah, you see right now we have this new column, success rate. Once again, guys, this is a stage of feature engineering. It's really important. What else do we need to do? We just rewrite our data set to have these new columns. Okay. What else can we do on the stage of feature engineering? Remember, guys, I told you that we have two columns of datetime format. Deadline. Just from the common logic, you might say that if the distance between project start and project finish is rather big, the more the probability that project will be successful. And the less this distance, the less is probable that project will be successful. You understand that if you put some project on Kickstarter and distance between your launch date and deadline is like 2 days, there is no way you will collect a lot of money. But if this distance is pretty big, the probability is higher. Of course, if your project is total trash, there is no way you will collect money even in years. But if this distance is too low, there is absolutely no probability to get money, even if your project is absolutely perfect, godlike. So based on this like common sense, which we apply to this, we can continue our feature engineering and create a new one based on these two columns. So we will just calculate distance between deadline and launch date. It's pretty easy. In pandas, you can do like this: df launched minus df deadline. Df deadline. Deadline. Yeah. By the way, I should do in an opposite way because deadline is bigger than launched. You see, it is possible to subtract one datetime column from another one. But this format of data is also not applicable for machine learning model. You need to transform it to be an integer or float number. You see, this format of data is time delta. So if you take two datetime objects and subtract one from another, you will receive time delta. Time delta is not usable for machine learning. So what you can do like this. You will use dt dot months. Let's try. Not months. Oh, what else? Maybe like this. dt dot day. Oh, serious. What is going on? I need to create a new column. Time delta.
You use not dt, you use df.
Series object. Sorry. Okay. dt dot months. No, it's not. It's not like this. Yeah. I'm absolutely sure that it is possible to execute integer numbers from this time delta format. But let's think what we are doing wrong. Okay, let's actually Google. It's absolutely normal. Time delta to months. Let's see how we can do it.
Not month, months.
Months. No.
You...
Months. Oh, okay. Let's try. No, not like this. Okay. NP time delta. No, it's not correct way. Oh, I can try. Let me check. I have the same problem. The same problem when I preparing for this lecture.
Maybe you should save it as a variable.
I think I should save it as a column and add it to my data frame. Let me check. dt.days. Let's come back. Classification time t.days. Yeah, okay, we're successful. We just not day but days, and this method for some reason has no months as attribute. Okay, great. Thank you for your help. At least, yeah, we succeed. Okay, instead of having this date format, not applicable, we will extract some integer features from it. Let's create new column, and this column will be days from lunch. Is it correct? Okay, let's say it's correct. What else can we do? We can execute seconds. Seconds, I think. Let's check it in another way, in another cell. of our notebook. Yeah, it has method seconds, and dividing seconds by 3000 by 60 multiplied by 60, we can calculate number of hours. Yeah, okay. Right now, we will create 3 new columns. One will be called days from launch. Another will be called hours. Hours. Let me delete this space. And another will be called seconds. We will just check seconds. Seconds. Okay, let's see. Yeah, okay, it is working. Let's see how our new columns is actually looks like. Days from, oh, I forgot to have this underscore here. Actually, you can create columns with spaces, but sometimes it's not kind of pretty easy to work with them. The space sometimes ruin your programming routine. So it's better to use underscore when you're creating column names. Okay, let's check new column. New columns. What is, yeah, I need to re-execute the cell. Let's check new columns. Yeah, we have 3 new integer columns. This is a stage of feature engineering. Based on datetime delta, we created new integer columns. Okay, and right now, let's try to combine our understanding of business problem. Our problem is to understand if project will be successful. And what else do we have? Let me add one more thing here to make it clear for you. We have goal. Yeah, you see, we have goal, I would say in USD. This is a goal in a local currency. Goal, USD goal real. Yeah, we will use this column, USD goal real. Let me demonstrate you. You see a number of dollars which author of the project want to get after the project will be successful, just to execute his project. And based on a feature which we created as a distance between start and end of a project, we can calculate how much money it is expected to get every day in order to succeed. So you understand, we have a goal of $1,000 and the distance between start and end is 10 days. So approximately $100 we should get every day to obtain $1,000 if you have distance 10 days. If you have distance 20 days, we should get approximately $50. So actually using these 2 columns, we can do one more step in our feature engineering. We can divide total goal in dollars by the number of days, for instance. And we will have a column which is USD per day, approximate number of dollars which author should get in order to succeed in his project. Let's do it. USD per day. To do so, we need just to divide one column USD goal real by number of days, df days from launch. Okay, let's have a look at our new column. I will just add it here just to make it better. Okay, yeah, right now we have a new column, and maybe it is not like guaranteed this column will be useful for our machine learning model. Okay, guys. So far, we discussed about how to work with datetime format of data, how you can subtract them, how you can extract months, date, quarter, and so on. Then we discussed how we can add new column based on aggregation. So you see here, we aggregated our data and then merged it into our data frame based on a key column called country. And also we discussed how we can combine these 2 methodologies and just create new columns based on dividing one on another. And you should understand that this process is really applying to your creativity, that you need to be really creative to understand how to create new columns, how to build these features from scratch. And this is all about like your understanding of business domain. If you understand how this Kickstarter is working, maybe you may create a much better features, much better columns. But if you have like just a like basic knowledge of this platform, you just saw it several times, this is all you can do so far. You just created some columns based on common sense. Nothing.
Dmitry,
Yeah.
question. Can we use the columns from another data set to put it in this data set and using pipeline? For
Okay.
example, average yeah, средний доход населения.
Yes, for sure. This is absolutely possible, and this is a good way to improve the quality of model. You can go to Wikipedia, wiki GDP per country. This is ВВП. List of country by GDP. For instance, you can copy paste this table and join it into your own one. But the problem that you need to transform this key column in a format which you have. You see here we have a format of countries, three letters: USA, Canada, Italy, Sweden, and so on. And here you have a full name of a country. So you need, first of all, find a function which transform all this name in a format of your key column. And then you need to just copy paste this column inside your Jupyter notebook. Yes, this is absolutely possible. And I would say many good data scientists do like this. Actually, let me demonstrate you one more feature that sometimes sometimes you can just copy this table into your clipboard and use this method pd read clipboard, and it will try to read this data frame based on your like copying buffer. So you see right now we almost succeed. We have some problems, but we can fix it. Just dropping columns totally of nones and so on. This sometimes it's useful. And right now, for instance, I just simply copied this table from Wikipedia. I need to transform this column with country and territory from this format to 3 letters. And then I can join it into my data frame and make a new feature. And this is a good way for feature engineering. Yeah. Okay. Thank you for your question. Great suggestion. Okay, right now we finished with our feature engineering. What will we do next? Next stage of our project, we need to actually transform our object features. We need to scale our numerical features, and we need to delete all the columns which is not usable for our machine learning model. To do so, let one more time check the head of our data frame. What we will do? We will drop this launched column, which is not usable. We will drop column deadline. What else? We will transform these categories using one-hot encoding. What else we will do? And we will scale this goal and pledged columns. We will scale them using standard scaler. Okay, let's do so. But before we do so, we need, I forgot one more important step. We need to do train. No, let's first of all check how many missing values we have in our data, because we did some transformation. And by the way, you see that one transformation that we did, we divided one column by another. When you are doing it, you should be careful, because you can divide by 0. And if you divide by 0, you will receive infinity in your data set. So let's check if you have some missing values in our data frame. Oh, yes, we have actually some missing values. We have 4 missing values in column name. We have 3,000 missing values in column USD pledged. Yeah, and that's actually all. Not so bad. Okay, and now let's check if we have some infinity values. To do so, what do we need to do? We will check this column. USD pledge equal to np.infinity. This is how you can access infinity using NumPy. Yes, right now we have another problem, that we have missing values, which is actually we can pretty easy fill with zeros, but also we have infinity numbers. You see infinity. And this is also very bad for our machine learning model. Machine learning model has no idea how to work with these infinity numbers. Okay, let's call this next stage remove nones and infinities. Yeah, sometimes you need to do it. Actually, almost always. How to do it? the very simple strategy we will just do like this: df equal, and instead of this, I will write this not equal sign. That I will use this Boolean mask as always. That if number is not equal to infinity, we will use it. If number equal to infinity, I just drop it. Okay, let's try to do it. Perfect. Let's check if after the transformation some numbers equal to infinity. Let's do it. Equal. No, right now we have 0 rows which has some infinities inside it. What can we do with our missing values? We can use method fill_in_a. And this fill_in_a method taking some arguments value. Which value you want to use to fill the missing value? For instance, let's use 0. No problem. This is quite possible. Okay. You see, on this small stage, we dropped all the infinity values and we filled all zeros with all missing values with zeros. Okay, next stage. Right now, we need to encode our categorical columns. Encode our categorical columns. Let's have a look. PD, no, df, sorry, why? First of all, we need to check which column is an object columns. Has type, is type. Yeah, the types. The types. The types equal to object. The types equal to object. Right now, I will just create a list of all object columns. Dot index. Yeah, I will store them. Object columns. Okay, and in the same manner, I will create numerical columns. Numerical columns. The types equal to int. Int 64. Okay, I need to check. Because right now what I'm suspecting that some of our columns is on type int32. You see, there is a difference between int64 and int32 types because number of bits, how many bits this variable is stored. And if right now I will write int64, it will be not correct because I will put aside all the column of type int32. So I need to find a method which allows me to get these values or these values. So for this purpose, I will use another type of Boolean mask when I'm using or equal int32. Okay, let's do like this. Okay, will it work? Something is wrong. Okay. Okay, numerical columns. Let's check. Okay, yeah, right now it's correct. I picked up all the columns of type int64 or int32. What else do we have here? We have some float columns. Okay, let's store them in another variable. I will call them float columns. Float columns of type float64. And since we don't have float32, I don't need this part of my equation. Float columns. Okay, let's check if all the names stored correctly. Okay, yeah, right now it's fine. Okay, we splitted all the columns in 3 different lists. And right now, let's apply our transformation. To apply our transformation, we will import our scalar from sklearn, preprocessing, import one hot encoder. Yeah, encoder. We need encoder. We will call this OHE, and this will be one hot encoder. Okay, we created instance of this encoder. What else do we need to do? We need to specify some arguments for it. I forgot to do as sparse sparse equal to false, and drop equal to drop equal to, I think it should be first. And object columns, let's see, object columns, name category, main category. One more thing I forgot to do, that before we will apply one-hot encoding, we need to check how many unique values we have in each object columns. Because if you have too much unique values in column, one-hot encoder will lead us to a huge dimensionality of our dataset. Okay. Def from object columns and unique. Okay. Oh, you see, if I apply one-hot encoding to column name, it will increase the size of my dataset to 375,000 of columns. So it is absolutely impossible to do one-hot encoding with column name. Column category is also rather huge. It has 159 unique values in it. So as you understand, if you apply one-hot encoding, it will create 159 new columns. So I would say that these two columns is not possible to be encoded using one-hot encoding. So what we can do, that instead of using one-hot encoding for these columns, we will use label encoding. Label encoding will lead us with one column, but this column will have 375 unique values in it, 75,000 unique values in it. Okay, let's also from sklearn preprocessing import label encoding. Label encoder. You see, this is this will come with your experience that you need to check if there is too much unique values. One-hot encoding is not applicable. If the number of unique values is rather small, like 10, maybe 20, you can use one-hot encoding. So right now, instead of using one-hot encoding to all columns, name and category, I will take these two columns and def, yes, and I will use label encoder on them. By the way, I need to create an instance of this label encoder. Label encoder. Okay, and also I will put this column here. We will create instance of label encoder and we will apply it to our column. Once again, we get some strange error. Apply fit transform. One more second. Let me check our previous label encoder fit transform apply. So, okay. Why it is not working right now? What does it write in? Got integer or string? Oh, yeah, I see. Remember, right now, as this is kind of interesting error message, encoder require you to have a string type, a type of an object. Remember last time we filled all the missing values right here with 0. df fill na with 0. So right now, column name is not only an object, like it has 99% of object type of strings, and the missing values was filled with 0, and 0 is an integer type. So actually we need to fix it. This is a kind of tricky thing that right now df.name need to be transformed as type string. Okay, we need to transform it back to a string type because some of these values is still integer. Okay, let's try one more time. If we succeed, Oh, perfect. Perfect. After three attempts, we succeed. We replaced all the strings with labels. Fine. Let's call this label encoded part. Label encoded part. Encoded part. Okay. Next, we need to transform our columns which has not a lot of categories inside it. Let's do it. Let's call this main category, currency. What else do we have? State and country. State and country. Okay. Let's try to do in the same manner as we do with label encoding. Will it work? Apply, and instead of label encoding, we will use one-hot encoding. Let's try. Oh, sparse output, leave sparse. Okay, what we have a problem, expected 2D array. Let me check how to solve it. One-hot encoder. Okay, I see. One-hot encoder, def, sorry. Instead of doing it like this, we transform def. Okay, yeah, right now we succeed. You see, instead of having these values, we have 0 and 1s in each column. Let's make it a bit clear using pandas data frame. Pandas data frame and columns equal to what we need to do. You see, right now this is a matrix, and this matrix is it's hard to understand what's going on inside this matrix. So right now I will try to make it better. Matrix, one-hot matrix, one-hot matrix. One-hot matrix looks like this, and one-hot matrix has also parameter feature names, maybe like this. Names. Let me check. It should has parameter get feature names. Okay. One-hot encoder get feature names. Get feature names out. Okay, yeah. You see, we took some columns, we created new features, and these columns is 0 and 1s. And now let's put it all together inside our PD data frame. Oh, PD data frame. Columns equal to this get feature names. Let's see. Yeah, perfect. The only one thing that we need to fix that right now it has all this column in float type, and I will transform them into integer ones. To do so, I will use as type int. Yeah, great. Now we have 54 columns. And how much we have initially? Initially, we have 4 of them. So taking 4 columns, and these 4 columns has 50, 14, 6, and 23 unique values. We ended up in 54 new columns. Okay, I think it's understandable. Let's call this type of data frame one-hot encoding part. Okay, now we have 2 parts of our data frame. One is after label encoding, another after one-hot encoding, and the last part, we need to scale numerical columns. Scale numerical columns. Okay, where I created a variable with numerical columns. Yeah, numerical columns. Let's see it. Def from numerical columns. We have many of them. To do so, we need actually import scalar from sklearn, preprocessing, import standard scalar. Standard scalar. Okay, let's use standard scalar. As always, we need to create an instance of scalar. Scalar, standard scalar. And then we need to use method fit transform. Scalar fit. Scalar fit transform of our numerical columns. Which one? Yeah, numerical columns. df dot numerical columns. Okay, we got some transformed columns. Let's also specify. This will be scaled matrix. And as we did with our one hot encoded columns, we don't use this matrix as it is because it's hard to understand what's going on here. We will put it inside our data frame. We will use pd.dataframe. pd.dataframe, we take this matrix, and as a columns parameter, we will specify numerical columns. Okay, let's see. Yeah, you see, instead of having all the columns on a different scale, we scale them. They right now all in the same range. Let me demonstrate you initial data from numerical columns. Initially, it looks like this. All the numbers were on a different scale. We applied scalar. All the numbers right now on the same scale. And right now, we can use this piece of data set in our linear models, because it's important for linear models to have the data on the same scale, numerical data. Okay, what else I forgot? We used one hot encoder, we used label encoder, we use scaling. What else we can do? I want to save this part as a numerical part. Okay, one more thing I forgot to do. We also has some float columns. Okay, we will try to transform them right now. Actually, I can do it here. If I took numerical columns, let me demonstrate you. df float columns. df float columns looks like this. Okay. I can df float columns plus numerical columns. It's not working. Okay, could not broadcast. Okay, but for these purposes, I can just copy paste this part of code, and instead of numerical columns, I will use float columns. This will be float part. Okay, right now we transformed label columns, one hot columns, numerical columns, and float columns. Now we need to put all of them together. We have 4 data frames. We need to put all of them, to concatenate all of them. To do so, we will use method pd_concat. pd_concat. We will took what we have. One hot encoder part, a label encoded part. Let me took all of them. A label encoded part, one hot encoded part. We have numerical part. How it is called? Numerical part we have, and we have float part. We will concatenate them, and we will concatenate them with x is equal to 1. And we will call this df final. Let's call it df final. Numerical part is not defined. Am I forgot to execute this part? Let's try one more time. Yeah. Okay, guys, we almost finished with preparation. You see, we did a lot of job. We encoded some columns, we scaled some columns, and instead of having 14 columns, we initially had 14, we have 78 right now. Now we almost ready to start training a model. Let me create a new variables to train our model. First of all, we forgot to take our target, to drop our target, and we need to do it on a stage of getting names of a column. You see right here, we took some columns, and inside numerical columns, this variable, we have our target. I think, no, it's not here. Where it is in float columns. Success rate, USD per each column. Guys, where is our target? How I called it? Year, month, quarter, year launched. They launched. They from DF. Target. Yeah. I find it finally. Okay. Next, we did all the preparation. Now we are starting with building model. Building ML model. You see, this is quite a common situation when preparation took like 60 or 70% of your working time. Preparing data is like most time-consuming part of all data science projects. And building a models, actually, it's like 20, maybe 25% of your work time hours, maybe even less, because preparing data is much more complicated part. Okay, to build a model, what we need to do? First of all, we need to split our data into train and test. To do so, we will import from sklearn, model selection, import train test split. Train test split is a simple function which allows us to split our dataset in 75 and 25%. What else we will do? We will create new variable df.train, df.test, and we will call this method train test split. And we will apply this train test split on our df final. Let's specify test size equal to 0.25%. So we will use 25% of our data to validate a model. Okay, let's do it. Okay, we split our data. Let's check the shapes of obtained data sets. df train shape, df test shape. Okay, we have 94,000 rows in our testing dataset and 283,000 in our training dataset. What else do we need? We need to split our features and our target. We will call it xtrain equal to df train drop target. Is it has target column? Sorry. df train dot target. Okay. I don't. Yes. Xtrain. In this case, we have y value is equal to df train. Yes. You see right here, I forgot to put target in our final data frame. In initial data frame, which we imported from Kickstarter, we have this target column. But right now, when I was creating df final, I concatenated 4 data frames, but I forgot to concatenate it with a target. So we lost actually a piece of information on what we are trying to learn. Target. df.target. Okay. Will it work? Okay, yeah. Let's check one more time. The shape of our data frame must, yes, it's increased. It's now 75. I lost one column, and this column was one of the most important ones. It was target. Okay, right now we need to create x and y. Xtrain is equal to df train drop target. We just removing this column from our training part of dataset. Drop target axis equal to 1, and y train We will put this column just away, df from target. Okay, and in the same manner, we will do for our x test. Let me write like this. And then we will just execute these cells. Okay, now we split it, train and test, and then train and test, we split it on features x and target y. And right now, let's try our baseline model. Baseline model. Baseline model is the simplest model which you can find in a classification problem. And as a baseline, I will use logistic regression. From sklearn, linear model, import logistic regression. Okay. We need to create instance of this logistic regression. We need to feed this instance logistic regression with X train and Y train. Here we actually show in our model that these particular features will lead to this result. Then what else we can do? We can check the score of our model on X test and Y test. And then after we trained our model on training part of data, on 75% of our data, we will check how good it will perform if we will hide a part of the data in X test. And we will do it in this row. Print. What else do we need to do? Like this, I will use accuracy. This will be accuracy. .3f. Let's run this. Yeah, I forgot fit. Fit is important part. Okay, we got some error. X contain none. Whoa. This is kind of unexpected. Remember, we have a part when we try to drop all the non-values from our X variable. But for some reason, right now, we still have some missing value in our train. Let's check it. Is an a.sum 82. X test. You see right now it's writing that I have a lot of missing values in my data frame. How it is possible? Let's check. Drop target, test size. This is fine. X is equal to 1. Df final. I will add a drop NA here. And let's try to restart our notebook. This is kind of unexpected because we have a special dedicated part when we dropped all the missing values. And right now, when I'm trying to fit it, it's writing that it has missing values. And this the thing which we try to avoid it during the process of our model training. Okay, USD per day. Okay, let's continue. USD per day, create this column. Okay. We dropped all the missing values right here, and we dropped all the infinity values. Okay. We continue. I'm just re-executing all the cells to find if we have some errors right here. We created 4 different parts of our data frame. We did train test split. And on this part, when we created X test, let's check if we have some missing value. Is an a.sum. We don't have. Okay. You see, this is an example of how it is important to restart your notebook after you did some transformation. Okay. We have some missing values still. Wow. Why it is so? Why we still has missing values if right here we don't have them? df.train, df.test, X test is NA dot sum. 0 missing values. X train 0, 0, 0. Okay. I can't understand it. Why it is so? Let me use one more command. 0. No missing values. Oh. Test. If we have it here, is NA dot sum dot sum. No, no missing values. Okay, it should be correct. No, it's not working. Unknown label unknown. Crazy. X train. Let me comment this part. Let's train it one more time. Something is broken. Okay, let's try to find what is missing here. Oh, sorry. Okay. Let's try to find what is missing here. We faced the problem that some values become missing after we did all the transformations. And actually right now, I don't see any reasons for this behavior. Let's think. Dev.train, dev.shape, logistic regression, xtrain, unknown label. Let's check all the columns. Okay. And xtest columns. They look pretty similar. And if it is equal to each other, yes. The columns in our train and test data frame are exactly the same. Let me check white train. White train is a set of true and false. If I use like this as type int, okay, right now it is better. Oh, I find an error. Great. Just type int. Great. Oh, after all, we finished this simple baseline model. You see, guys, I forgot one thing, and I told you many times about it, that machine learning models don't understand anything but numbers. If you try to put some data which is not numerical one inside your machine learning model, there is no way you will succeed. And I made this mistake in my example because Y test is Boolean type. It is type object. It is still not numbers. And if I want to plug it inside my machine learning model, the only way I can do it, I should transform it into numbers. Instead of using true or false, I should use 1 or 0. And that's why I was failing with my machine learning model. Okay, so here I will use as type equal to integer. And here also as type equal to integer. Let me re-execute this part of our seminar. Okay. And yes, finally. Okay. You see, we trained logistic regression. Actually, I can delete this part because I transformed it previously. And the accuracy of our model is 0.64. What does it mean? To understand what is accuracy, you need to understand one more concept. I will demonstrate you. Metrics, import confusion metrics. You need to use confusion metrics. Confusion metrics take two arguments. It's y true and y predicted. So here you see I didn't create it y predicted, but to do it, I can use just method predict. Predict y test. And I call this variable y predicted. Y predicted. Okay. Import confusion matrix. And inside this matrix, I will put y test. our test labels and our predicted values labels. Okay, you see, we built this model, and from this confusion matrix, you can understand. You see, it has 4 values inside it. This 61,000, 0, 33,000, and so on. It has 4 values in it. And based on this matrix, you can understand how many labels, which is actually true, was predicted as a true by our model, and how many labels, which is actually false, was predicted as false by our model. This is called true positive and true positive and false negative rate. So another way to represent your confusion matrix, you can store it in a variable, confusion matrix. Confusion, okay, let's just call it confusion. And you can use a Seaborn heat map of confusion. Let's also plt.show. Let's also use method. What method do we need? Not equal to true. Okay, let's try to do it. Okay, yeah, you see, this is a confusion matrix. Let me add a few more details. X label equal to true labels and Y predicted labels. On Y axis we have true labels on Y, and on X axis we have predicted labels. How you can read confusion matrix? This is really important, that you need to understand how to read it. You see that predicted label is 0. Our model says that this project will fail. It will fail. It has label 0. And in reality, true label based on our test data is also 0. And we have approximately, let me print it one more time because here it's not really visible. And we have 61,000 of samples, which is really failed, really failed. And our model says that it will fail. And we have these values here. And another example that true labels was 1, that project really succeed. And our model, on the contrary, say that this project will fail. We have 0. And on the intersection of these two labels, we have value of 33,000. So our model predicted that 61,000 project will be successful, and it is correct. And 33,000 of project will be failed. To calculate accuracy, you need to divide the diagonal of this matrix. Diagonal of this matrix is true positive plus true negative. So here is true positive. It is 0 and it is 0 here. And here is 1 and 1. And you need to divide it by the total number of observation. And total number of observation is true positive plus true negative plus false positive. False positive is when model predicted 1, but in reality it is 0. It is here, this part of confusion matrix. And plus false negative. False negative means that model predicted 0, you have it here, but in reality it is 1. So this is called false negative. And this is a formula for accuracy. Accuracy equal to this. Accuracy equal to this. Okay, so from our result, you can simply calculate accuracy like this. You take 61 here, which is predicted correctly. This is a true negative. True negative equal to 61,000 plus 0. 0 is this value of 0, which is true positive, because true positive is 0 here. And you need divided by the total number of observation. And total number of observation is 61,000 plus 33,000 plus 0 plus 0. 33,000 plus 61 plus 0 plus 0. Okay, this is how you can calculate accuracy by hands. Invalid syntax because I forgot 0 here. Yeah, and you see we have the same value as we have here when we called this method model.score. Okay, guys. Okay, guys. This was our first model, and we understand how we can validate it when we are dealing with classification task. Remember, last time we talked about regression problem. In regression problem, you cannot use confusion matrix. It has no labels. You cannot say what is true positive, what is true negative. But in classification task, you always use matrix which is based on confusion matrix. You always train a model, then you call confusion matrix, you check what values you have here, you plot it, and then you can calculate accuracy, precision, recall, and all of them. All these metrics in a problem of classification based on this simple plot on a confusion matrix. Okay, let's try to use another model. Another model is decision tree. Decision tree. Remember last time when we tried to solve a problem of regression, we also use decision tree. But this time we need to call another type of tree. Last time we used decision tree regressor. It is regression problem, regressor tree. Right now we will use decision tree classificator. From sklearn.tree import decision tree classifier. You see, we need to create an instance. It will be called decision tree classifier. And then we need to fit it. It's quite simple. Fit with X train and Y train. We will predict some value if pred Y pred 3. To do so, we will use instance of this model, predict X test, Y predict 3. And then we also will use this score matrix, accuracy. Okay, let's do so. Accuracy of 3. Well, let's try to train it. If we will succeed, we will see some score. It's taken some time. Because right now our dataset is much bigger than it was previously. Oh, it's really taking a lot of time. Okay, yeah, you see, we trained our tree and our accuracy is even lower than it was previously. Okay, it is quite fine because we didn't do any job about improving its performance. Let's do the same job as we do for logistic regression. Right now, we will plot confusion matrix for our decision tree. What we need to do, we need just to change this one variable. It was ypred for logistic regression, and we change it on ypred for decision tree. Let's see. Right now, you see, we already has not zeros here. Let me also check this confusion matrix. Right now, if you will try to plug all these values in our formula of accuracy, which is here, true positive, true negative, and so on, it will be different because right now it's not 0. But we can simply call this method and our accuracy is even lower. Accuracy is a measure of how good your model from 0 to 1. Okay, what else? We try decision tree. Let's try to change hyperparameters of our decision tree. To do so, let me join this part of our code. And next, we will try to decrease the height of our tree. Max depth equal to 5. Let's do like this and train another tree. Okay. You see, I changed this hyperparameter. Yes, you see, right now I was able to increase the accuracy of my tree. I changed one simple parameter and accuracy become bigger. Also, we have more samples, which is predicted correctly. You see here we have 4,000 approximately, and here we have 6,000 of samples predicted correctly. Okay, that's fine. Actually, let me try to as type int. Maybe it will work like this. To make our metrics better. No, it's not working. Okay, let's try another type of parameters. Is what else? Max features. Okay. No, let's try to play with max depth. I still like it better. Let's use max depth equal to 3 And let's check some other parameter. What I want to do is splitter. Yeah, criterion. Yeah, criterion. Let's use criterion equal to entropy. Let's try. I just picked up another type of hyperparameters, and you see the performance is not much better right now. Okay, that was a model of decision tree. We did all the preparation, and now it's extremely simple for us to plug different models, to play with their parameters, and to measure its performance, because we did a good preparation. Let's try two more models, and we will finish for today. Another good model is random forest. And what I need to do to train a random forest, if I did all the preparation, I just copy paste, and instead of decision tree, I need to import random forest from sklearn ensemble. Import random forest, and you see we have two random forest, regression and classifier. We need classifier here. We use random forest classifier. We delete these hyperparameters. Max depth equal to 3, and instead of tree, I will use a random tree. Okay, let's try to train a random forest model on our data. It's pretty simple. You see, training a machine learning model and validating it on a test data took like 10 lines of code for me, because we did all the preparation. Preparation in data science project, it's like 70 or 80% of work, like getting features, finding what is wrong with your data. You see how many errors I made today, that we have missing values, we have some values which is infinity, some values which we need to drop, some values of different type, which is supposed to be strings, but they are integers. Okay, maybe we'll train our random forest. Yes, we trained our random forest model. Actually, it's not really good. Let me change hyperparameters. Let me actually delete it and run it with default parameters. Maybe it will be better. By the way, still till this model is training, we can try another model, which is called, what else? We can try XGBoost, gradient boosting. Gradient boosting. Oh, which is so it's taken a lot of time to train a model, so we may be not in time to train another one. Okay, it's already 15 seconds training. Oh, maybe I forgot to use one parameter. Let me check. Oh, yeah, guys, you see, I forgot to use parameter n jobs are equal to -1, and I am not using all the power of my computer at this point, so it's taking a lot of time to train this model. Okay, guys, unfortunately, we are not able to train one more model, and we need to finish in 1 minute because we have next lecture. So, guys, today we talked about classification problem. Last time it was regression problem, and like from the basic point of view, you need just to know the difference. You need to know what you should use for regression problems, that you need all the models which has regression in its name. You need to know what you want to use for classification problem, all the models which has classifier in it. You need to know how to operate and transform your data, how you can transform labels using one-hot encoding, how you can scale your data using different scalars, and how to know the difference, which data you need to transform with one-hot encoder, label encoder, or scalar. This will come with your experience. If you become experienced data scientist, you will know the difference. Today, we also talked about interesting process of feature engineering, how you can get new parameters for your model, machine learning models, based on existing ones, just from your common sense, from your understanding of business background. That's actually all for today. Oh, we finished with training our model. We have accuracy of 0.644. Is it better? No, it's not. It's not even better than our decision tree. But it's quite understandable because we didn't play with hyperparameters of this model. You know, it's also extremely important step that you just not call your random forest as this. You need to play with all these parameters, which is written here. You need to understand which one to choose, how to optimize them, which like combination of parameters may lead to best result. This is also a kind of about your knowledge, about your creativity and understanding of models. But from the basic point of view, it's really simple. You just write a few lines of code and the model is trained, you evaluated it, perfect, good results. Okay, guys, on this point, I am finishing today's lecture because we have next one. Thank you for your attention. In next lecture, we will try to work with neural networks. We will try to solve a problem of classification, but not with tabular data, but with pictures. So it will be interesting. Hope to see all of you. I think it will be on Saturday. So today is Monday. It will be on Saturday. Also, guys, thank you to all of you who submitted homework. I will give you a feedback in 2 or 3 days. And see you next time. Thank you for your attention. Thank you very much.
Thank you.
Thank you, sir.